from the nucleus. You can imagine the enormity of the empty space that an atom is. Alright, now the nucleus is now understood to be, let's now consolidate the atomic theory proposed by Rutherford. What do we know? The nucleus is now understood to be composed of protons and neutrons, particles of nearly equal mass. You can see I use protons red and neutrons green. This is the nucleus that consists of protons that are positively charged, neutrons that are electrically neutral, and they coexist, making up the nucleus. Protons and neutrons together are called nucleons. Nucleons or nuclear particles, right? The number of protons and neutrons together is the number of nucleons. Now, elements differ in the number of protons and neutrons in the nucleus of their atoms. Well, and that is the difference in the elements. Now, the simplest element is hydrogen. We will talk a lot about hydrogen as we go on in today's lesson. The simplest element is hydrogen. The nucleus of hydrogen contains just one proton. The ordinary hydrogen contains just one proton and one electron going around it. That is the hydrogen atom, the simplest atom. So you must have a picture of the hydrogen atom in your mind. Just one proton and an electron around it is our hydrogen atom. An element is identified, I want you to remember this. An element is identified by its atomic number and represent the atomic number by the letter Z. And the mass number. Mass number is identified by the letter uppercase A. So an element is identified by its atomic number, which is Z, and mass number, that is uppercase A. Now what is the atomic number? Atomic number of an element is the number of protons in the nucleus. The number of protons in the nucleus. So tell me, what is the atomic number of hydrogen? Hydrogen has one proton in the nucleus, therefore its atomic number is 1. Alright. A is the sum of the protons and neutrons. Mass number is the sum of the protons and neutrons. Alright, tell me in that case, what is the mass number of hydrogen? The mass number of hydrogen also is 1 because it has no neutrons. So the mass number of hydrogen is 1. The atomic number also is 1. Now if n is the number of neutrons in the nucleus, then the number of neutrons will be the mass number minus the atomic number. You see, if the mass number of an element is 22 and the atomic number is 10, what does that mean? Let me ask you this. If the mass number is 22, that means A equal to 22 and the atomic number is 10. Well, remember, the atomic number is the number of protons. There are 10 protons. And the mass number is the number of protons and neutrons. So if you add the number of protons, that is 10, to the number of neutrons, you get 22. So what is the number of neutrons? The number of neutrons is the mass number, that is 22, minus the atomic number. Now in this case, that will be 12. Okay. The nucleus symbol. Now every element is represented by a nuclear symbol. Every element has a symbol. And in this case, I'm simply going to use X. Now, what are some of the symbols? Do you know some of the symbols? All right, let me show you some of the symbols. We will talk about that as we go on. Now, hydrogen is H, so H stands for hydrogen. He stands for helium. Now, some common elements, Fe stands for iron. Now, we talked about gold. Gold is A sub G. You see, that is gold. Now, Cl stands for chlorine. C stands for carbon. Well, we will come across all these elements as we go on into the 2 or 3 lessons from today. So every element is identified by a chemical symbol. So if I use X here, that X will be replaced by these when we talk about each of these elements. So the symbol of the element, an element is identified by its symbol, then its atomic number, and its mass number. These are the 3 things that we use to identify an element. Now look at the way an element is written. This is the symbol of the element. The atomic number is written at the left bottom corner. The mass number is written at the left top corner. This is the normal way to write, to represent an element. So XZA, X stands for the symbol of the element. Z is the atomic number, which is the number of protons in the nucleus. And A is the mass number, that is the number of protons and neutrons. For example, lithium. Lithium is an element, and the nucleus of that element contains 3 protons and 4 neutrons. Alright, lithium, Li is the symbol, Z is the number of protons, that is 3, A is the number of protons plus the number of neutrons, that is 3 plus 4, 7. So how will we represent lithium? Look at the way. Li37. This is the way we represent lithium. Can you now write in one of the papers that is in front of you the symbol for hydrogen? How do we represent hydrogen? Alright, have you written? The atomic number is 1, mass number is 1. So ordinary hydrogen can be of different type. But this is the ordinary hydrogen, H11, 1 proton and no neutron. So atomic mass is simply the number of protons. Alright, now this is the ordinary hydrogen. Soon we will see there are different types of hydrogen. We will look at that as we go on. Well, this is the time to look at those isotopes. Now, an isotope, an element, you see the nucleus of an element can contain some protons and some neutrons. Is that right? Now, it is the number of protons that identify the elements. Now, there may be other forms of the same element. That is, atoms of the same element. Now, how do you know they are of the same element? Because of the same atomic number. The number of protons will identify the element. For example, if the nucleus contains 6 protons, irrespective of the number of neutrons, that nucleus belongs to carbon. Carbon has 6 protons, you see. So, if the neutrons are different, then you have different kinds of carbon. So, atoms of the same element can have different numbers of neutrons. Right? Now, that doesn't make an element different. It is the same element. As long as the number of protons are the same, the element is the same element. But different forms are the same element. Different possible versions of each element are called isotopes. So, isotopes of an element are different versions of the same element. Means the nucleus will contain the same number of protons but different numbers of neutrons. Now, for example, the most common isotope of hydrogen has no neutrons at all. We talked about it. There is also a hydrogen isotope called deuterium with one neutron. There is a form of hydrogen that contains one proton and one neutron. And yet there is another form of hydrogen that contains one proton and two neutrons. Now, this is the ordinary hydrogen. It contains just one proton, and that is H11. You see, one proton and no neutron. And most of the hydrogen in the universe is this. But you can have a different type of hydrogen, one proton and one neutron. This is still hydrogen. Why? Because the number of protons is just one. How do you write the symbol for this? It will be H12. One proton and one neutron. Remember, this number is the number of protons plus the number of neutrons. 1 plus 1 equal to 2. Now, this isotope of hydrogen is called, what is it called? Deuterium. Deuterium. In fact, when you produce water using this particular hydrogen, it's called heavy water. Heavy water because we are using hydrogen that is heavier than normal hydrogen. And look at the third isotope of hydrogen. It's got one proton. As long as the number of protons is the same, it is hydrogen. It has one proton and two neutrons. And look at the way it's written. H13, one proton and two neutrons. The mass number is 1 plus